Welcome everyone to today's Explainer. We're tackling a fascinating and honestly pretty urgent challenge today, managing the wildly opaque world of AI risks. We're going to explore exactly how the ISO/IEC 4200 standard helps us take that terrifying black box and turn it into a beautifully transparent process. Because let's face it, if you work with AI, develop it, or even just rely on it, governing these systems is no longer optional. So let's dive right in and illuminate this whole thing together. Okay, I want you to think about this massive question for a second. If your AI makes a mistake, who's accountable? When a model denies a loan, or misdiagnoses a patient, or mistakenly flags a totally normal transaction as fraudulent, the fallout is absolutely huge. Lives and livelihoods are literally on the line here. And when the dust settles, we have to figure out exactly who takes the fall. Is it the developer, the data scientist, maybe the executive who bought the software? Without a seriously structured management system, answering that question is a total nightmare. So here is our roadmap for today. We'll start with the AI threat landscape, move into categorizing the chaos, look at the auditor's shield, explore cracking the black box, and finally wrap up with continuous vigilance. Starting off with Section 1, the AI threat landscape. AI fundamentally breaks all the rules of traditional risk management. Think about it. In traditional IT, a system failure usually means a static bug in the code or maybe a burned out server, right? It's binary, it's predictable. But AI is probabilistic. It learns dynamically, and its logic can be incredibly opaque. It might make the exact right decision 99 times in a row, and then the 100th time, it makes a completely baffling error just because of how it weighted one tiny specific data point. You can't just patch an AI with a simple line of code. You actually have to manage its entire behavioral ecosystem. Which brings us to Section 2, categorizing the chaos. To actually tame these wild AI risks, the ISO standard breaks them down into three neat little buckets: ethical, security, and operational. Let's look at the ethical bucket first. Algorithmic bias happens when AI systems inherit and literally amplify the human prejudices that are hidden inside historical training data. Think of a recruitment AI used to screen resumes. If it was trained on a decade of data from a predominantly male workforce, the AI might actually learn that male equals to successful hire, so it starts unfairly favoring male candidates over equally qualified female candidates. And look, this isn't just a technical glitch. That is a massive compliance, legal, and reputational disaster waiting to happen. Now, on the security side, we're facing threats that your traditional firewalls just cannot stop. Enter adversarial attacks and data poisoning. Imagine a government facial recognition system. A bad actor doesn't even need to hack the database anymore. They can just apply tiny, completely invisible to the human eye alterations to an image that totally trick the AI into misidentifying a suspect. Or think about data poisoning, where attackers slowly feed malicious data into the AI's training pool so the system learns the completely wrong rules from the start. It's essentially psychological warfare against a machine. And for our operational bucket, we have the dreaded black box. This is when an AI system's processes are not transparent or even understandable to human operators. Imagine an AI loan approval system rejecting applicants. The bank officer doesn't know why, the customer doesn't know why. Literally, even the developers who built the AI cannot pinpoint exactly why that specific decision was made. And the problem here is when you lose transparency, you completely destroy accountability. Let's move to Section 3, the auditor's shield. So, how do we actually protect ourselves? Well, the ISO 42001 standard gives us a highly logical step-by-step framework to organize our risk management. First, we identify the specific AI risks, like the bias or adversarial attacks we were just talking about. Second, we assess their likelihood and impact. Basically, how bad would a failure actually be? Third, we mitigate and treat those risks through concrete controls. And finally, we monitor continuously, because as we know, an AI is never truly finished. It's an ongoing, constant cycle of improvement. Now, the absolute crucial point here is documentation. Clause 6.1.2 of the standard strictly mandates a documented methodology to assess these risks. Let me be clear. Auditors do not care about your good intentions. They require hard, documented evidence of your analysis methods. If you say your AI is fair, well, the auditor is going to ask you to prove it. You need to present that documented risk matrix and the likelihood severity mapping. Everything has to align perfectly with your organization's established risk tolerance. All right, Section 4, cracking the black box. This is where we get to the really fun part. This is where we turn that opaque black box into a beautifully transparent glass box using explainability tools like SHAP and LIME. Since ISO 42001 demands documented analysis methods, these tools give us the mathematical proof we actually need. These are basically our flashlights. SHAP, which stands for Shapley Additive Explanations, allows us to map out exactly which specific feature or data point caused the AI to make its decision on a global scale. And LIME? That provides localized transparency, showing us why a specific individual prediction was made. So instead of just blindly trusting the algorithm, we can generate hard proof of exactly why it decided what it did. The standard is incredibly clear on this. Explainability is completely non-negotiable for critical applications. Going back to our HR example, if an AI recommends an employee for a major promotion, or conversely, flags someone for termination, a documented SHAP analysis lets everyone see the exact factors driving that choice. It might show us that tenure and project success were the driving features, rather than demographic data. This is brilliant because it satisfies the user's right to understand the decision, and it perfectly satisfies the ISO auditor who's looking for documented transparency. Finally, Section 5, Continuous Vigilance. Here's the thing. Our work is absolutely not done just because the AI is deployed. AI models are living systems interacting with a constantly changing world, so we have to meticulously monitor for drift. Model drift is when the AI's performance just generally degrades over time. Data drift happens when the real-world input data changes, like maybe consumer behavior shifted overnight because of a global event, but your AI is still acting on old data. And concept drift? That's when the fundamental rules change. The relationship between inputs and outputs is just no longer what the AI originally learned. If we aren't documenting and monitoring for all of this, our perfectly trained AI will slowly but surely become dangerously inaccurate. Let's actually look at this monitoring in practice on a factory floor. We document a baseline performance metric, say an F1 score of 0.95. We set a strict documented threshold at 0.92. Now, by week 3, the performance drops to 0.91, crossing our threshold. Because you're following the standard, our automated pipeline flags this concept drift immediately. This means a senior engineer can step in and retrain the model in week 4, long before an assembly line actually breaks down. That right there, that is proactive risk management in action. So, I want to leave you with this provocative thought. Is your AI a black box, or is it a glass house? Unaccountable decisions made in the dark are just no longer an option. The ISO 42001 standard gives you the rigorous tools you need to ensure your AI is transparent, ethical, and continuously monitored. Thank you so much for joining me for this explainer.